Hi, my name is Sean Sarwar, and I'm a systems engineer here at eHealth Africa. Today, we want to introduce you to the Aether platform. Before we do that, we'd like to say a few things about who we are, what we do, and why we felt the need to create Aether in the first place. So eHealth Africa is an NGO. We're roughly 600 people, most of whom work from our offices in West Africa. We have a small technical team here in Berlin, but the bulk of our team are in Nigeria. We partner with ministries of health, INGOs, and others to create and improve systems that improve health. Before I talk about the Aether platform, I thought we should spend a few slides covering the background issues that caused us to start this project. To set the stage a little bit, the technical side of EHA functions partially as a development shop and partially as a systems integrator. We've launched hundreds of projects over the past 10 years. And we find that generally, the long-term survival of a project relies on it not just being completed and adopted, but also maintained. And these days, it has to play a role in a much larger set of systems, solutions, and workflows. EHA's beginnings were geared more towards a services focus, and in many cases, it kind of acted as a first responder. Some critical need would pop up, sometimes an outbreak. The team would move in and build a system. It would get deployed, and generally everyone would be happy. The team on the ground would have typically started from scratch by copying a previous project or have some other boilerplate they would use. Later on, the organization asking for the solution would find other uses for it or want to add capabilities, and this quick and dirty project would now need to be evolved and maintained. Oh, and by the way, we need to share that data or generate some reports that hadn't been in the spec, and so on and so on. So we need to get to production quickly, but also reliably. You can go a long way with the efficiencies we just described. So we know that starting a project is the easy part. The longer you run successfully in your niche, the more likely you are to encounter some of these common issues. First thing that usually happens is that someone, be it a partner or funder, will want to leverage data from your program for some other purpose. If, for example, you've mapped out all the previously uncatalogued settlements around Lake Chad, chances are someone will come along and want to use that data for an immunization campaign or a survey. The list goes on. Siloed programs have limited impact, so it's crucial to be interoperable. Secondly, someone's going to ask far after the project has been launched, is the system secure? And are you appropriately protecting personal privacy in your potentially very sensitive system? The developers will generally swear up and down that these things were considered, but in the best case for a one-off system design, there's probably not a huge budget making sure critical components of the system are easily patchable when the vulnerability is discovered. And lastly, someone's going to ask for a capacity that you hadn't considered, and it's going to cost much more than your budget because it wasn't in scope. It will sound trivial to them, but it'll be something that you need developer time to accomplish, which is impossible because those developers are on to the next thing. And it can't be easily outsourced because it requires understanding of a code base that was maniacally assembled in something like 8 weeks. So before we delve into Aether and how it addresses those issues we just talked about, I want to define a few terms that are going to be used. So the term schema refers to the organization of data kind of as a blueprint of how the data should be expressed. On the left side here, we have an example minimalist schema for a person. In our definition of a person, they have a first and last name, which are text, and an age, which is a whole number. For a piece of data to represent a person, we demand that it contain their first and last name. On the right side, we have a piece of data that complies with our schema for a person. If we had included this person's date of birth instead of their age, the piece of data would not be valid according to our schema. We also want to talk about normalization. And normalization is the process of restructuring a schema in order to reduce the redundancy and improve data integrity. The table on the left represents customers and their transactions with the business. The list of transactions is nested within a field titled transactions. To normalize this data, we move the transactions into their own table using the customer ID to reference the person who initiated the transaction. Normalization allows database operations to be more efficient. For example, in the normalized data, it's much easier to calculate the total amount of all transactions completed in October. Nested data of varying length can also be called jagged because its structure can be unpredictable. So what is Aether? Simply put, it's a platform of software and services built around best practices. The Aether platform provides common capabilities like security, data storage, transport, schema definitions, etc. Having these things baked in allows the dev team to focus on the actual solution and not reinventing or recoding the wheel. Solutions become easier to deploy, maintain, and upgrade than a one-off traditional project built from scratch. And by building on a common foundation, the software development process becomes more well-defined, predictable, and repeatable. The idea is to take lessons from the field and reuse code where we have been successful to give the project a nice head start. And we think that Aether really hits the sweet spot for some of the use cases that EHA typically sees, where we need to collect data or move some data, which requires a little bit of data manipulation, but not full-blown ETL, or maybe some simple workflows like a supervisor approval. They might be deployed on-premise, or it might require a deployment in a high-trust AWS cloud environment, and it should also fit our DevOps model well. Where those capabilities are insufficient, we've left many hooks for adding capabilities to Aether. If we need better ETL, we can become more robust by embedding an application like Apache NiFi. Or if we need a feedback loop with an external BPMN tool, we can add that along as well. Aether really is more of a systems integration exercise than, again, a lot of recoding the wheel. Where we did want to expend significant developer effort was in making it easier for systems to handle data in the right way. We find that too often data definitions are treated as an afterthought, an artifact that lives somewhere in the code or as a result implicitly of API interactions. Instead, we want explicit, easily consumable, and communicable schemas. By building a platform with schema data as a core tenet, we can provide considerable utility to the solutions built upon it. A couple key features of the Aether platform. Aether collects structured inputs from a variety of source data using data contracts. Data contracts specify how each input data is mapped to common definitions. By using data contracts, Aether ensures interoperability between data producing and data consuming applications. Processed data is stored as messages, which can be read or published to external applications. Software developers are free to develop connectors for unsupported or custom applications using the Aether SDK. Patient privacy is also assured by masking or transforming personal records into something compliant. Aether can be deployed using high-trust cloud environments such as AWS, Google Cloud Platform, or Azure, as well as on-premise deployments in order to reinforce security and better manage data sharing workflows. I want to focus on how Aether addresses the first challenge we talked about, which is interoperability of data and interoperability of systems. So we codify some concepts within Aether that we feel help people build interoperable solutions on the platform. We believe data should have a schema. We believe that normalized and linked data is usually better than nested and jagged. We believe that schemas change, so a message should have its schema available to make available to downstream users. The world doesn't typically adhere to these ideals, unfortunately, and we can't enforce them outside of Aether. Many of the inputs that we get are basically big, ugly data locked into spreadsheets. So we make it really simple to extract input data into normalized types called entities. The lingua franca of Aether is JSON. We have a modular system that allows developers to create input modules for other data types. And by providing a mapping step for inputs, we can take very ugly data in, transform it, and make it available for publication to a standards compliant system. We also take a modular approach when it comes time to publish data to external systems. All data in Aether is stored in a stream of similar datum called a topic. Output connectors are developed for a specific output system or standard. For example, CCAN, which is a web-based open source management system for the storage and distribution of open data, or JDBC, which is a generalized method for communicating with relational databases. Each connector can subscribe to any or all available topics on a system, form transformations of the data to a format predefined by the downstream systems, and send data to them in real time. These are capabilities that the platform exposes. It becomes evident why we want to do these things when we look at the solutions to some of our use cases. The first common use case that Aether supports is data collection, curation, and publication. EHA builds a lot of systems that rely on people filling out forms, submitting the data from the forms to a central authority, having some approver check the data, move the data into a system of record, and then make that data available to decision makers. Use cases could include censuses, health facility registries, disease surveillance collections, just about any use case where humans in the field need to post data to a central location using browsers, smartphones, or perhaps only SMS. The problem here is that data comes in a wide variety, kind of wide and ugly, and with very little metadata. And most of the metadata that is there is implied in the forms themselves, but can come in with the JSON document implicitly. So the first Aether-based solution built solves this use case, and it's an application called Gather. The solution has been deployed in 3 countries, with 2 more projects currently being put in for production. Gather uses Open Data Kit as the input module and basically manages survey forms, survey projects, and the data that's collected. This also highlights a case where data coming in has no formal schema and every record is ugly. Aether provides tools to formalize and reshape the incoming data where needed. We can optionally do things like extract entities in order to normalize the data. A major goal for Gather is to allow data collection to start within hours of an initial request, with the option to easily add structure and connections to downstream systems as the situation evolves. Gather also uses an Aether output connection to CCAN, publish survey data to a data portal. We try to leverage external systems whenever possible, particularly on the output side when there are many great visualization tools. Another interesting use case comes from smart vaccine refrigerators. As you may know, many vaccines must be kept cold but above freezing to remain potent. Vaccines that are left the acceptable temperature range should be destroyed generally rather than being administered to a child. And to track this, many up-and-coming technologies around refrigeration send detailed telemetry messages back to a central server. And this data can include things like temperature alerts, available electrical voltage from a solar grid or generator power source, or the operating status of internal electrical components and their error messages. A country might have different models in the field at once from a few different manufacturers, and their log formats will be individual, and the content can be very different, even though there's significant overlap in the content of the captured data. The Ministry of Health might want to manage this equipment and have different applications for the data from these appliances. So the ministry itself might want back operational data to know which fridges are online so they can order maintenance and don't deliver vaccines to a facility that's offline until it's back on. A research partner of the ministry may need a subset of the operational data to study effectiveness of the different models of fridges deployed in different power configurations across the region. And the manufacturer itself may want all telemetry data from their fridges to understand durability issues that occur in the field. Lastly, the power company may want to receive alerts about its grid when power becomes unavailable at a health facility. So coordinating these types of communications via a messaging standard for all fridge manufacturers would require significant consensus from all the involved parties and be a quite difficult process to formulate. Aether lets us ignore the formats of the individual various inputs and focus on their content. We can create 3 classes of entity and populate them from our inputs. For example, the class of telemetry data, which is everything, but in the manufacturer-specific schema, we could create a class of operational data, which is out-of-range alarms and temperature tracks, which would be generic for all fridge types. And we could have a power data type that's input voltage and power supply type, which is, again, generic for all fridge types. We can then publish this data to the various stakeholders automatically using rules for masking and publishing. So the ministry would get all operational data in the common format for all fridges. The manufacturer would get data from their fridges in their own proprietary format. The research partner would get a subset of the operating data with sensitive fields removed. And the power company would get a real-time reading of the status of their power from all fridges that are connected to their grid. All these capabilities are built into Aether, requiring only configuration. If we were to build a solution for these types of refrigeration systems, we would have to work on building an administrative interface tailored to the use case. But from a total development work standpoint, we're already about 80% of the way there. And that's what Aether brings to us. So what's next? We're continuing to spec and build solutions, and we're approaching a large internal milestone. On July 1st, we'll be hitting 1.0 and releasing Aether as an open source project under the Apache 2 license. You know, it takes time and effort to build a community, so we're starting that tonight. If anything we talked about here piqued your interest, please stay tuned. Open source is not just for developers, so don't be intimidated if Python is more of a snake than a language to you. There's always ways for everyone to contribute. Thanks for your time.